thank you very much for inviting me today, and thank you all for taking time after lessons to come and have a listen. I believe I've got about 15 minutes, so I will have to talk quite quickly because this subject is very interesting and there's a lot about it. And just want to tell you a bit more about the centre. So the centre's been open since 2008. And we were very lucky to be given a big grant from another charity to open the centre. And the work that we're doing is groundbreaking legacy work, because Nottingham was the first place in the world where the link between the immune system and cancer was discovered. So you could say that Nottingham is the birthplace of immunology. So what do I mean by immunology? Let me explain a bit more about what we do. We're going the wrong way, there we go. So what we do is look at cancer cells to try and find ways to save lives, speed up the diagnosis of cancer, and then find ways to treat it. So that's the mission statement, for want of a better expression. So it's all about managing clinical management of patients with cancer. So 1 in 3 of us, this is a scary statistic, 1 in 3 of us will get cancer in our lifetime. That's actually, doesn't mean you're going to die, but from a simple carcinoma or melanoma through to the kinds of cancers that you read about in the papers, where by the time you've been diagnosed, something like pancreatic cancer, where by the time you've been diagnosed, it's so late that probably only 7% of people are going to survive the cancer. So right across the spectrum. So it's important to all of us, and you guys are much younger than me, and a few of the other people in the room, but some of you, even at your tender years, will probably have experience of some of you in your family having had cancer. And it's a scary thing, and the work that we're doing at the centre is about trying to understand it better, manage it better, and make it so that it's not such a scary thing and that people don't die so often of their cancer. So it's all about finding the cancer quickly, so diagnosis is very important. It's about finding out which patients will respond to which treatments, and then it's about developing vaccines that will work with the body's own immune system. So this isn't about finding new chemicals and new chemotherapies and things like that. This is about finding things in your body that will help the help your own body to fight your cancer. So it's called personalised medicine, and it is fascinating. Now, I'm not a scientist, but if I was the age you guys are, I'd be thinking about career change, because I'm working with world-class research scientists who are very inspirational, and every day I go to work and I enjoy what I do. So we work very closely. We do what's called translational work. So it's not just happening in the lab, it's been translated out into the clinic. So we're working with clinicians, oncologists, patient support groups, to take the science that we're working on and experiment with it and try it out and work with patients to see how it's happening. We also use some really cool equipment, so if any of you want to come and have a look, I can show you that. So those are the things that we're specifically looking for, so new immunotherapies and something, what we call decision-making biomarkers, which are very subtle differences between cancer cells and healthy cells that distinguish whether cancer is present and what's happening there. The four sciences are immunology, genomics, proteomics, and bioinformatics. So I'll explain very quickly what the differences with those. So again, back to what I said earlier in terms of immunology, this is about understanding the difference between the healthy cells and the cancerous cells, and developing therapies that will help to treat the cancer. Genomics and proteomics, this is a simplistic view, but basically genomics is the study of genes, and the proteomics is the study of proteins. And again, we use pretty cool kit to look at that. We use equipment that can take a cell and or population cells and count them and analyse what they are at something like 70,000 cells a second. If I tell you that on the top of a pinhead, you can fit 100,000 cells. And in a minute I'm going to show you a little animation that will show you the sort of scale I'm talking about. But this machine can process cells at that speed, and you can tell it that you want to look for a particular cell, and it will count these cells and it will pick out the one you want. It's called a cell sorter. So you can actually take a single cell, stick it into a little pot, and then take it away and mash it up. And I don't know if any of you are doing science subjects here, but you'll understand about being able to, the skill of being able to get down to a tiny cell and then take it away. Proteins are like little robots in your cells, and they are doing the machinery of clearing out dead cells, and they behave very differently in your cells depending on whether you just had a cup of coffee, or you've been for a swim, or you've had a sleep. And those changes are happening in your body all the time. What we're trying to find is the change between what's happening in a cell that's got cancer and the cell that hasn't got cancer. So we use very sophisticated equipment called mass spectrometers to do that. And we break cells up. The bioinformatics, which is the fourth strand, is very clever maths. Again, I'm not a mathematician. I famously got 10% of my chemistry level. I did pass my maths, but I'm working with these guys who have got brains the size of the planet. And they take the data that's coming out of all these different sciences, and we get millions and millions of bits of data, far too much for the human brain and the human eye to interpret. So we use bioinformatics, which is mathematical algorithms to process the data. And it can take up to 2 weeks to process a few million bits of data. So one of the things we are trying to do is speed up the processing at the moment. So we've got very clever computer software guys writing new software for us to speed up the pace of the processes. We also have an issue with storage. And again, I don't know if any of you are doing computer sciences, but the amount of data that we're creating is filling up computers faster than you can blink. We've got 2 of the biggest computers in the whole university. So we're looking at using gaming cards to start storing the information. So something like Call of Duty has huge amounts of data. It's tiny little chips. So we want to be able to use that technology to store all the huge amounts of data that we're creating. So the mathematics. So if any of you are thinking, why do I do maths? You could be ending up doing this one day. It is fascinating. So this is just an example of, I mean, that's not a real cell, but that's just obviously an animation to show you what the difference might be. But what you've got going on here is genes being expressed all the way around the surface of the cell. And what we're looking for is the differences between what's going on around that cell and what's happening with the cells here. Basically, we're playing a sophisticated game of spot the difference, because we're trying to find these different characteristics. So I won't wait for you to find the differences, but basically we're looking for spot the difference. The problem is, in our case, the spot the difference is looking for a straw-coloured needle in a haystack the size of a city. So that kind of gives you the scale of the problem that we're looking for. As well as the science, we work with a number of colleagues to look at the other factors that can affect you. If you have a compromised immune system, you will get cancer. No doubt about it. Your body is fighting it all the time, and if your immune system is healthy, because you're eating a balanced diet, you're exercising regularly, you're not getting stress, at your age you should be getting stress. If you're avoiding viruses and things like that, there are genetic factors, so you might have an inherited gene, but all of those things can affect your immune system. If your immune system is working well, you won't get cancer. If we switch it off, you would get cancer. So when somebody has a transplant, an organ transplant, the body is programmed to reject foreign tissue. So what we have to do when somebody is in the transplant ward, we have to give them a drug that suppresses the immunity, so that the body will accept the new tissue, and then they can go on to live a healthy life with a new kidney or something. But quite a lot of people who have that kind of treatment do end up developing low-grade tumours. And so once that happens, they have to be monitored all the time. Once that happens, we have to sort of take the immune suppressant drugs away and build their immune system back up again. And you would hope that by that point the body's accepted the new organ. So there's a spectrum of switching it off and switching it back on. And we're trying to get to the end where you can switch it back on again and stop people getting cancer. So I'm going to go to, just as a sort of a summary for you as to why I'm really here, apart from to tell you other people about what I do, is that we have got a fundraising campaign going on over the next 4.5 years to raise enough money to not just provide the scientists with the wherewithal to do the research, but also to take any of these potential biomarkers and run them through into clinical trials. And I don't know how many of you understand how long it takes to develop new drugs and new vaccines, but it requires several different stages. You have to test things on computers first. You do have to test them in animal models, and before you can put them into humans, and that's the law. And then you have to do different stages of clinical trials, and as you get through the different stages, the patient cohort gets bigger, so the cost goes up exponentially. So it's very expensive to do cancer research. So part of my reason for being here today is that if you guys are going to help to fundraise for us, that would be an amazing thing, because the scientists need funding. I'm going to go to a web page to just very quickly show you what I'm talking about in terms of scale, because hopefully you'll find this pretty fascinating. If not find what I can't. So this is actually on the University of Utah website, and I'm going to have something like this on our website, I think. So this is, obviously that's not to scale coffee bean, but those are to scale with each other. If I just run along here, at the moment all you can see on there pretty much is the sesame seed, the grain of rice and the coffee bean. But if I start to run along here with this, if I can get it, grab it and move it, as we zoom in, you can start to see other things appearing that you can't see with the human eye. So you've got amoebas and spawn. Look at the scale of sperm and human egg. And then skin cells. So already you can imagine that skin cell, you can't see that with the human eye. Red blood cells. Let's keep going along here. And just wanted to show you, this is the sort of level that we're working at. Getting smaller and smaller and smaller and smaller, things that you can't see. Now when I talk about breaking up proteins, this is about the level we're talking about. That's the sort of similar size to proteins in bones and things. Stuff you can't see with the human eye. And we have this very sophisticated equipment that takes us down to breaking things down to their component parts. So that's the sort of level that we're working at. It's pretty fascinating stuff. And the first time I saw that little graphic, I was just going, oh my God. So I hope that you found that as fascinating. I'm just going to show you one more thing, which is one of our animations that we've done, which is, we'll talk about personalised treatment, and it will just hopefully explain to you a little bit more about what we're doing.
We know that the body's immune system can play a vital role in the fight against cancer. Cancer immunology is the study of the immune system and its interactions with cancer cells. Cancer cells can exist and thrive in the human body when the immune system does not recognize the cells as something that should be targeted and destroyed. Therefore, it allows the cancer cells to reproduce and in some cases spread to other parts of the body as secondary cancer. If we can understand why cancer cells can go undetected and ignored by the immune system, then we can develop immunological treatments such as vaccinations that will stimulate the body to recognize and fight cancerous cells. But before such treatments can be developed, we need to understand what it is that we can target. The differences between the genetic and protein makeup of a cancer cell and a non-cancer cell can be minute. Our scientists use cutting-edge techniques to identify these different features, known as biomarkers. So, once a specific difference has been discovered, the results can be passed on to our immunology team for the development of immunological treatments such as antibodies or vaccines, which can trigger the immune system to target the cancer. The advantages of these immunotherapies are many. They have far fewer side effects than the traditional treatments such as chemotherapy. Immunotherapies such as cancer vaccines induce the attack of the primary tumour and also any disease that is spread. The immune system also has memory, so if the cancer tries to return, it can attack and destroy it more quickly. We have already made great strides in understanding the relationship between the immune system and cancer and the development of immunotherapies such as cancer vaccines. Treating cancer can never be a one-size-fits-all approach. Our research is revealing much about this diverse disease and will result in more personalised and effective approaches for treating cancer.
That's the name of the campaign, and thank you very much for your attention.
Hi everyone, my name is Karen. Caroline and I work for Centrepoint, the youth homelessness charity. Thank you so much for having me here to speak to you today, I really appreciate it. So I've been working at Centrepoint for just over a year now. I'm the relationship events assistant, which means I work with the fundraising team. So, Centrepoint. Centrepoint is a youth homelessness charity. This means that we work with 16 to 25-year-olds across London and also in the northeast of Sunderland. And we've recently just started working in Bradford as well. We work with 16 to 25-year-olds because we believe this is an age where people can really change their lives for the better. It's really hard once someone becomes accustomed to living their lives on the streets to actually change that. It becomes really ingrained in them. So Centrepoint tries to target young people before it gets to that point, help them change their lives and on the path to independent living. A survey done a couple of years ago found that there are 80,000 homeless young people in the UK. 80,000 is absolutely shocking. It is the equivalent to 1 in every 100 young people in the UK, which I just thought was an awful statistic and really shameful. Centrepoint supports over 8,400 16 to 25-year-olds in the UK into housing and independent living every year. So who comes to Centrepoint? As you can see, this infograph gives you a little bit of information as to the kind of backgrounds of the young people that come to us. Often these issues correlate with each other and provide a web of complex support needs which really makes it more difficult for young people to move into independent living and change their lives. So I'm just going to show you Monique's story now because she can explain so much better than I can the work that Centrepoint does. She's an ex-resident and she has an absolutely incredible story to tell.
About 15 when I got kicked out. It was just after a really big argument with my mum where we squared up to each other, and my dad said he couldn't live with both of us anymore, so one of us had to leave. He actually packed my bags and told me I needed to leave. But I was sort of drifting from one place to the next, so I never really had a place that I could actually call home. When I was at my lowest point, I just felt really helpless. Because not only was I homeless, but I felt like I didn't have anything to live for. I didn't have any sort of certainties about what I would do next, and instead of looking to the future, I was just taking each day as it comes. So that uncertainty made it hard to sort of have hope and to carry on. After a while of sofa surfing, it all became too much for me. Mentally, I felt really weak. Being homeless and also the situation with my family and feeling so isolated from everyone else led to me being depressed. Eventually, I got referred to see the Child and Adolescent Mental Health Services, who diagnosed me as being clinically depressed. They didn't think that I was safe to sort of be on my own anymore. I'd already previously made a few suicide attempts and I'd started to self-harm by this point. Altogether, I was in hospital for about 7 months. I was at rock bottom. I didn't really have any mental strength. When I was finally ready to leave hospital, as I didn't have anywhere to go, they decided to refer me to Centrepoint so that I could stay in one of their hostels. It was so much more than just a roof over my head because as well as physically being there, they were also there for me mentally.
As a mental health worker, if a young person required my support, I would go and take my service to them and see them in a private one-to-one room by offering that person the right type of support that they would need. Kind of like identify what they want to achieve in life, what their ambitions are, what their goals are, drawing upon their strengths.
And that's when I realised that I want to make something of my future and I want to do something that puts all my newfound mental strength to the test. And that's when I decided to take up powerlifting.
It is a rewarding job, yeah. And I think with young people, change is natural anyway. I think it's just pointing people in the right direction.
The Centrepoint supported me and financially paid for me to go to my first ever international competition. I'm now a 3-time world champion.
So I just wanted to show you that video because I think it's such a good example of a Centrepoint story that works out brilliantly well. Monique's an absolute...
They stole her childhood. Those selfish, damaged parents.
Sorry about that. But yeah, I just wanted to show you Monique's story because I think it's absolutely incredible and it's such a good example of someone that's come to Centrepoint, as she said, at rock bottom and changed her life and completely moved on to independent living. So this graph kind of very basically shows you the kind of route that the young people take when they come to our services. Obviously at the very top we offer accommodation first and foremost. We get them off the streets or wherever it is that they happen to be at the time. For example, in Monique's case, she was in hospital. We get a lot of care leavers, so all sorts of different situations. We offer accommodation from anywhere between 9 days to 2 years. Obviously the 9 days is a very short emergency stay for people who have come straight off the streets. 2 years is kind of the maximum amount of time that we tend to have young people with us, and we hope by the end of that they've grown and they're now able to move on independently. I'll talk about the health and wellbeing and the learning team a little bit more in a minute, but we also have the policy and participation team. So they actually lobby government on a local and national level to try and get the needs of young people to be listened to and considered when government are changing policy. Out of that team, we also have the Centre for Parliament, which is a group of young people elected by all the other young people in the services who then represent the views and the voices of all the young people we have. They also work with the policy team to help them lobby government, and they hold us to account as well, which is really important because if we're not providing what we say we are, then we're failing these young people. Finally, we have the Move On team, and they are there to make sure the young people have the practical, social, and mental mindset to move on to independent living successfully. Every young person that leaves us has support and where they'll go next, and they're supported for up to 6 months. So the health and wellbeing team, every young person that comes through to us has a health assessment as soon as they're there. Within a month of reaching us, they have a health assessment. Being homeless obviously takes its toll on a young person's physical and mental health. We have a huge variety of services we provide. This is just some of them. I'm not going to stand and read them out because I'm sure you guys can still read them yourselves. I just wanted to tell you a few facts that I always think are really poignant. Mental health problems are 8 times more likely for young people living in hostels and 11 times more likely for those who have slept rough. Despite this, just 7% of Centrepoint young people who come to us with a mental health issue have had it diagnosed. 69% of homeless young people say they only eat 2 meals a day, and only 4% say they manage 5 portions of fruit and vegetables a day. The learning team work with homeless young people to help them get back into formal education, vocational training or employment. 29% of the young people that come to us have no qualifications to their name. I only left university 2 years ago, and it took me a hell of a long time to get a job myself. The thought of trying to do that without any qualifications must be absolutely terrifying. I can't imagine being in that situation. And that's what the learning team does. They help these young people on their way. The work they do is incredibly varied, as you can see, ranging from ICT qualifications to sports programs, CV writing to job fairs, pretty much everything you can think of. We also run an innovative Workwise program, which is a 6-week job-ready program. At the end of it, the young person will get a level 2 BTEC qualification, as well as a load of employability skills and work experience. We actually had a young person do work experience in our funding team. They were supposed to be there for 4 weeks, but halfway through they actually got a proper job. So I think that's a brilliant example of the Workwise program actually really working. So fundraising, which is my understanding of what you guys are going to do for us. I think fundraising is absolutely brilliant. I started doing it in uni and continue now as my job. Just to make it clear, the accommodation that we provide is mainly paid for by the government through the Young People's Housing Benefit. So that and statutory funding pays for the accommodation side of it. Everything else that I've just talked about is all voluntary income. So that's income from people such as yourselves, from companies that we work with. all voluntary income, trusts, anything you can think of like that goes towards everything else, and that's what makes Centrepoint really special and helps these young people move forward with their lives. I think it's an incredibly rewarding thing to do, because you can take something that you feel passionate about and turn it into a fundraising opportunity. As you can see, all these people have done such a variety of different things, and they all raise so much money doing it, and I always think that's a really powerful thing. And our fundraising team are here to support you with whatever it is you'll be doing. So that's everything I wanted to say. Thank you so much for having us here today.
Thank you for coming to talk to us about the wonderful work that you guys will be doing with the money that we are raising from our DLD charity work. Thank you, both of you.
Thank you.
Anybody have any questions about either of us, about what we do? You want to know more? Okay.
Come on, Mike, you can think of something.
Are we doing any activities for helping the Centrepoint thing?
You want?
So would you like us to take part in anything specifically to the college?
Well, we can use volunteers for quite a lot of our events. Something that we often need volunteers for are things like coming to the marathon and just cheering our runners on. I mean, running a marathon sounds awful, but we do have a huge team of volunteers who kind of cheer everyone on. Things like that are absolutely great. In terms of actually coming to services and that, it's something that we can look into. We don't tend to do it with people that are under 18, but it's certainly something we can consider and look at in the future, absolutely, yeah. If you did have anything that you kind of wanted to experience or see for yourselves, please feel free to get in contact and we'll see what we can do.
I'll ask a question.
Yeah.
Can I ask for both of you, just to give us an idea, if we were to raise £1,000 for each of your charities, what do you think that would sort of achieve? Is there a way of sort of gauging what that money would actually do for both your companies, your charities, sorry?
Wow. Obviously, as I said earlier, cancer research is an expensive thing, and at the upper end you've got some very expensive equipment, but at the lower end it is possible to sequence a gene for as little as £10, which is taking a gene and pulling out all the elements about it. Obviously there are lots of them in your body, so to do it for, one day we hope that we'll be able to map somebody's whole gene system, like you've got the DNA now, but to do it across somebody's whole system. So money like that, at any level, money is going into the work that we're doing. But as I say, at the bottom end of the scale, to something like £10 to sequence a gene. So it would be very useful. It would get used to in a myriad of different ways. But just to give you an example of the scale, from the sort of £500,000 equipment at one end and the cost of a clinical trial down to sequencing a gene. So your money could go towards sequencing somebody's genetic system to help to find out whether a particular treatment would help to diagnose their cancer or even treat it. So it would be very, very usefully put to purpose.
Yeah, exactly the same with us. We have kind of big expenditure needs and smaller expenditure needs. So it's all about, if you wanted, you could choose a kind of one of the teams that I mentioned earlier that your money could go towards specifically, and then we could look at breaking it down and seeing exactly what you wanted to pay for. But you have to think of it in terms of these young people often come to Centrepoint with absolutely nothing, so every penny does help them move on with their lives. £5 pays for a hot meal for a young person. They may not have had one for months or even years. That's such a small amount of money but makes such a big difference to someone. You could talk about, about 30 quid will pay for an outfit that will help them at a job interview. You can't turn up to a job interview with kind of very casual clothes on, so something like that, 30 quid, £1,000. I'm not sure how that works up divided up, but that's a lot of outfits for young people who have job interviews coming up. So yeah, it would make a huge difference to us.
Good question. Okay. If you raise a big amount of money to the charity, will we change the genetic thing, the biology thing?
All the money that comes into the work that we do is about making discoveries in genes and proteins and developing the. So every penny goes towards that. One of the things I didn't say was that the university underwrites the running costs of the, so the heating and estate costs and things like that. We don't pay for any of that because Nottingham Trent University covers all that. So every penny that comes into the centre goes directly towards the research, which is a good thing for you guys to know, so you know that it's not going to be frittered away on rubber bands and paper clips.
As is rubber bands and paper clips.
No, this isn't a rubber band. This is a wristband, Olivia. You know that. I'm wearing one for something very practical. So it's important that when you're raising money, that you do get to know where it's going, because you want to know that it's being spent wisely. So those are good questions.
Do you have small samples?
Do we have? I haven't got any with me, but I can get you some. Yeah, we can get you some gizmos. Yeah. I never thought about bringing gizmos and widgets. Silly me. You had.
By that you mean the money going to the equipment or to the actual?
No, well, the research is the cost of the scientists and the consumables that they use. So the stuff that they're doing every day, rather than paying for the cost of heating the building or running the IT or insurance costs or whatever. So the university picks up what called the overheads, so that the money that's raised can go directly to the research and operational research. Some of the consumables that we use are very, very cheap, and some are very expensive. Some of the technology, say the mass spectrometer, the new mass spectrometer that we use at the moment, cost £500,000 to buy. And in fact, actually, we haven't bought the latest one, we've leased it. And it's a bit like leasing a car. We've got it on the basis that if the next time there's a new upgrade, we get the new upgrade. And we just had delivery of the latest version of a Canadian equipment. I couldn't tell you what the model is, but it's the first one in the UK. We've had the first one in the UK, which is a big thing. And the old kit from 5 years ago used to take 17 hours to run a series of programs. The kit that we got in January, which was the new model, not the latest model, the new model, which we leased, could do the experiment in a couple of hours. The upgrade that we got a fortnight ago can do it in an hour. So in 5 years, the technology's gone from 17 hours to an hour to run millions of bits of data. And the work that we're doing with that equipment is cutting edge, and the people that make the equipment are sending people from Canada to work with us, because the type of work that we're doing with them, and mass spectrometry would normally be in the chemistry lab at the university, but we have it with our biologists, because we're using it in conjunction with the work that the genomics specialists are doing to break down these cancer cells into their tiny component parts, so we can look at what the behaviours and the difference in behaviours are. And that's not actually happening routinely in cancer research labs across the world, because the bigger organisations have you understand when I say in silo, so they're working separately in different departments or different organisations, and ours are working very closely together so that we can combine those different disciplines to achieve quicker results. So it's very exciting. I mean, that's a career in science. If I was your age, that's what I would do. It's just amazing.